Someone asked me to look up a very vague statement, something called the R value and then the name of somebody. And that led to a rabbit hole, as it always does. And it ended up me finding someone who had several channels that they used to sell products on. Maybe they were a sales representative or something at one place or another, or maybe they were doing it to make money off of AdWords or whatever. Doesn't matter. But the person running these 3 or maybe more channels at one point made a major change, and there was almost a year of no postings, or they were deleted afterwards, I don't know. And new postings showed up that were off topic, and they were all very fixated on some form of conspiracy theory kind of thinking. I just finished doing a video where I addressed the entire reason I do videos debunking things that are not true. I'm not even calling them conspiracy theories, just anything that isn't true, I will debunk. I'll also find out if there's any truth in it, what its origin story is, and that sort of thing. But anyway, someone just left a really, thought-terminating cliche short sentence on the channel. Hey, look up this name and the subject of R value. Now, when I dug into it, I found the words R value and that name only led back, obviously, to the person who had the channel, and exclusively R value is a term, expression, thought-terminating cliche, or buzzword more accurately, or salesmanship, brand naming kind of thing, little registered trademark thing going on, for this channel. And R value very simply refers to a way of also explaining the diameter of the Earth, because it's the radius of the Earth, or how deep is the center of the Earth from wherever you're standing. And I decided to go off on the subject of how much of a pain in the ass it is to actually map, and understand the actual shape and diameter and all the facts and truisms about the Earth. And it gets really, really specific and very, very detailed, but I'm going to review it really quickly. A model of the Earth as you would do in a video game. And this includes the methodology you'd use for a solar system. You start off figuring out, by observation, how far away all of the planets are from the center of our solar system, which is the sun. Understanding that the orbits will be circles, or vaguely like it. And then you'll alter them to be ellipsoids or other shapes. And same thing with the planets. And you can generalize these very easily. Some of the planets are gas giants, so they're very spherical, but then again, they don't have a definitive starting and stopping point for the atmosphere and then space. Even Earth has a cutoff point at around 50 miles, but that's not really accurate. And you end up having to just accept that you're going to generalize these first layer. So first test, let's say for the solar system, is you draw a pinpoint in the center representing the center of the mass of the sun, and then a center point mass for all of the other planets. And you put them in a straight line at first, just to model them. And then you make a single value, the R value, as he's calling it, or the radius. And that makes a spherical shape that fits those. And you put them at a specific distance. So you have distance from center, sun, diameter, and you also make the sun have a diameter. And you draw them on circles. And you draw the orbits as a circle. And this is something that I at one time memorized to make a little space game. And it's approximated it by using a single value, which at the time was not one astronomical unit. It was actually the unit distance from the center of the sun to the center of Mercury. And then a specific set of multiplication values were used to stretch it out. But you could round it off to double, triple, quadruple, octuple, or something like that to draw out the diameters of the Earth and everything like that. Mathematically, they're very similar. And then you could also put in rotation value, how fast they go around the sun and how often they rotate per rotation. You can make it like a gear mechanism almost. In fact, you could draw it as a gear mechanism. And that was also a way, mathematically, to map out the interior of a pocket watch. This kind of mathematics involving single number values can be used, again, with another thing. You can include a stretch value or a distortion value for stretching out the orbit so that they're elliptic or egg-shaped or whatever you want by just using the mathematic algorithm for drawing that circle or drawing that orbit. You could also include inclination by tilting their orbit a little bit, which works for only a few of the planets. That's only needed. And on some of them you can make it to where they're not just pointed straight up and down. You tilt them like the Earth is. One of them's tilted like this. Some of them have a negative value. They're upside down. And when you do all that, you end up with an approximation that draws the solar system, first blush. So you can enter the solar system and fly through with your spaceship, and you can see the shape of the solar system. Okay. Then you get close to a planet. A lot of them obviously you don't have familiarity with, it doesn't matter. So you just draw a color pattern first, just to get the colors on. And then you do a black and white line drawn map over the top of it with slightly higher resolution. You don't need high resolution for colors. Humans just generalize colors. And you end up with something that's almost photorealistic just by doing that level of compression. But you're drawing it. And if you do it just right, it'll look ridiculously close. And that's used in Stellarium and a lot of other programs. They don't try to make it perfect. They just make it just look good enough that you won't notice. Most people don't look through a telescope at anything other than the moon. And now we get to the moon. When you draw the Earth, you, again, don't have to make it perfect because everybody has a vague idea what it looks like, and you can just put a picture of the Earth over the top of it. Maybe even just one angle, but you usually just wrap it around. And then for the moon, you only need one side because humans only really observe one side of the moon. We call it the bright side of the moon, not the dark side, but it's just the side that faces the Earth, and it always seems to do so. It really does. It just slightly changes a little bit, the waxing and waning. And that's a good enough approximation. Until you actually use it to figure out, if I do a AR, augmented reality, with that heads-up display, or just your cell phone, you notice the moon's in the wrong location. The stars aren't lined up correctly, so you correct it. And then it's corrected. And then if you turn around, I swear to God, if you just turn around and you look that way, it doesn't line up anymore. So you recorrect it. And then suddenly it's figured out, oh, you're at a certain altitude, because it's able to figure out, because they don't line up right, that it's estimating an altitude at sea level and you're in Colorado, Boulder. And that's enough of a change just for altitude, Mile High City or whatever, that it has to correct it just enough that it makes assumptions better. It gets it from the GPS, but it might not know the altitude, because internally the program is just assuming the Earth is smooth. Next layer, you draw actual physical alterations in the shape. Again, it can become egg-shaped, which is more like the Earth, for instance. It's wider than it is tall. That's another very minimal alteration. And again, these can be mathematically driven. And suddenly, the math algorithm works really good if you do that for the Earth, to where when you use that cell phone app or that AR routine, they line up really good. They're not perfect, but they're really, really close. It's good enough to spot a star or figure out where you're supposed to look for a comet. And then you want to navigate with it. Oh, well, it's using GPS data, most likely, if it's your cell phone, and it approximates where you are, but you're on the north side of the street, and it says you're on the south side or in the middle, so you have to correct it a little bit. See, there's always this little level of correction. At one point, it was a mile-high city. Now we're 20 feet. When I do a video game level, I use what's called the generic street model. You draw a street with sidewalks, 2 of them, even if you're not going to have them. It's just a flat surface you embed in, and you give it a cement pattern. Then you cut into it with the road pattern that has a built-in super that you approximate as just 2 angles. You just reduce the number of polygons. And that's it. But streets aren't always the same width, and not every street has 2 sidewalks, and some of them have sidewalks with trees in them. And you add detail, but that's good enough. If you're in an airplane, doing a flight sim, but once you land, you're like, every street's identical, all the shops are just this vague color. So you have a level of detail, each layer deep. Now we get to the problem. Even mapping a human head, video game activity, you start off with an egg shape. Then you chop pieces out of it. You create height maps or displacement maps, or various methods like that, used to alter it to where you have accuracy that gets rivaling that of a photo. You can do very, very well. You can even tell it, oh, this is skin and this is hair, so we do these lighting effects. And suddenly it looks just like a human. Until they try to smile or talk, and then it's really creepy because it's just close enough that it looks like a person who's possessed or infected or psychotic. That's what that creepy feeling is. And the Earth is the same way. You're walking along in your VR environment, overlaying over your car, and it shows you a bridge that isn't there anymore because it's got outdated data. That's a temporal error. There's a problem. The map's wrong. It's just a game. The shape of the Earth is not really relevant. Most of us don't actually experience it. We experience everything in 2D worlds where we ignore the fact that if you took these 2 square maps, put them next to each other. They're supposed to connect here, but they don't really connect at the right angles because the Earth is a sphere and they don't meet at the same angles. And the roads drawn from point A to point B are drawn that way because we can ignore what's in the middle because nobody lives there, so the maps don't have to work correctly, and there's the distortion. It's puckered in a little. The right angles aren't right. And you get this uncanny valley thing when you first learn to do mapping, when you spend time being a surveyor, where you hit that limit where you're at the point and you say, we have to adjust for 50 feet here? Yep. But that says that this is puckering by 50 feet to this point, like it's some sort of distortion in time space. No, that's just where they chose to put it. So it would be between two counties and a state. And, well, what's the fourth point? Well, the fourth point, it's not there. This is a triad point. Huh? All sorts of mystical sounding words. It just means that they had to warp the map so much to make it all flat that they ended up with this chunk that was shaped like this, an Illuminati triangle out in the middle of the forest that is ignored. It's not on the maps. You find them everywhere. These are the compensation points or the diddle spots or all sorts of names. Triangular, square, some of them are cube-shaped. Well, they are. They are missing entire hills and mountains. Some maps show a mountain that's bigger than it's supposed to be because they never compensated the map error. So the map's showing it bigger or smaller, depending on what part of the state you're in. States that are almost perfectly square, which would be nice to make a map out of, aren't. Because you can't make a square surface on a sphere. This is what you learn. Successive approximation or level of detail or whatever you want to call it makes it to where, as you're doing the fiddly bits around the fjords, you find out that mathematically you can't figure out the coastline length. You can't do these things. It's impossible. Because reality is incredibly resistant to being mapped as a simplistic idea. I could at one time quote almost perfectly, if I just sat there and derived it using mathematics, all the positions of the planets on a particular date, and then mathematically move them forward a certain number of degrees to where I could put them exactly where they should be, and then I could point to the sky, you point a telescope there and find that planet based on data from 1970 or 1950. I could do all that math. At one time, I could sit down and show you where all these pucker factors are in the map, where they distort them inward or outward to compensate for the fact that they made square maps of an area you really shouldn't do that with. Going so far as to distort the shape of a mountain range so they could just make the map lay down flatter, hiding the mountain. Because the map makers decide how they're going to draw reality, it's almost like an artwork. I've been there, done that. And when people point out that they discovered this like it's a new thing, like a paper street, because you saw Fight Club, this is when I sit there and say, okay, here we go again. And that's reality. Reality doesn't give a shit if we know about it or map it correctly. Hell, we can't see infrared and ultraviolet. At least most of us can't. I can partially see some ultraviolet and some infrared. Most of us can, but you just don't know it. We don't see it. We just detect it. Meanwhile, mantis shrimp can detect shit. We can't even imagine what the fuck they're detecting. We still don't know what it can see. And it's a fucking sea creature. And it punches hard till you bleed. And it's about that big. And it'll sucker punch your foot. We, as a species, are limited by our perceptions, and ignoring that gets us killed. When you drink and drive, you're taking everyone's life in your own hands. When you assume, for some reason, that you are much smarter than you are and go off and do something dumb, you're putting everyone's life at risk. And everyone needs to recognize that. And spreading misinformation is an example of that. Don't do that. Thanks for watching. Have a good day. Good luck with that.